There is a tablet that costs less than $1 to make at your kitchen table. You dissolve it directly inside your car battery, and within 72 hours, a battery your mechanic told you was dead comes back to full cranking power, full voltage, full capacity, as if it rolled off the assembly line. Not a $220 replacement battery from AutoZone that comes with a 2-year warranty conveniently designed to expire 6 months before the battery dies on you again. Not a $90 CTK smart charger with a so-called desulfation mode that independent testing shows recovers 5 to 12% of lost capacity on a good day and 0 on a bad one. Not a $45 battery tender trickle charger that maintains whatever charge your battery has left, but does absolutely nothing about the chemical degradation that is actually killing it from the inside. Not a free dealer battery health check that exists for one single purpose, to print a receipt that says replace in red letters and charge you dealer markup on a part you could have saved for less than the price of a candy bar. This tablet does not bypass your electrical system, it does not modify your alternator output, it does not require a mechanic, a scan tool, or a single minute of professional labor. It reverses the specific chemical process that is responsible for 80% of every battery failure in every vehicle on every road in America. A retired postal worker in Michigan had a 2014 Honda Accord sitting in his garage all winter. Battery was stone dead. Not dim headlights dead. Not slow crank dead. Nothing. No dome light, no dash, no click when he turned the key. His neighbor told him about this formula. He made one tablet, dissolved it, connected a $30 charger from Walmart, and left it overnight. 48 hours later, he turned the key and the engine fired on the first crank. That battery is still in his car 14 months later. He keeps a Ziploc bag of tablets in his glove compartment like breath mints. A single mother running a daycare van in Georgia was quoted $520 by a fleet mechanic to replace both batteries in her 2016 Chevy Express. She treated both batteries on a Saturday morning while her kids watched cartoons. Monday morning the van started like it just left the dealership. She spent $1.40 total. The $520 went to school supplies. An RV owner in the Arizona desert had 2 deep cycle house batteries in a Class C motorhome. Capacity had dropped so low, the refrigerator would not run through the night. He treated both batteries with this formula. Capacity returned to 85% of the original factory specification. He has been boondocking off-grid on those same 2 batteries for 2 full seasons without spending a single dollar on replacements. No mechanic, no tools, no wiring knowledge. You do not even need to remove the battery from the vehicle. You pop the cell caps, drop the solution in, connect any charger you already own, and walk away. The chemistry does the work while you sleep. This formula has been documented in electrochemistry research since 1935. It was tested by military engineers, published in peer-reviewed technical journals, and then systematically buried by an industry that sells Americans 150 million replacement batteries every single year. And now you are about to learn exactly what they erased. If this knowledge matters to you, subscribe and hit the bell right now, because what comes next will permanently change the way you look at every dead battery you have ever thrown in the trash. To understand why this tablet works, you need to understand the single biggest design failure that every car battery has carried since the day the technology was invented. In 1859, a French physicist named Gaston Planté took 2 sheets of lead, rolled them together with a strip of flannel between them, submerged the entire assembly in a jar of sulfuric acid, and created the first rechargeable lead-acid battery in history. It was a revelation. For the first time, electrical energy could be stored chemically and retrieved on demand. And the fundamental architecture of that battery, lead plates submerged in sulfuric acid, has not changed in 166 years. Every car on every road today starts its engine with a battery that is structurally identical to something a French scientist built before the American Civil War. The problem Planté could not solve, and that no battery manufacturer has solved since, is sulfation. Here is what happens inside your battery every single time you turn off your engine. When a lead-acid battery discharges, a chemical reaction converts lead dioxide on the positive plates and sponge lead on the negative plates into a compound called lead sulfate. When you drive and your alternator recharges the battery, that reaction reverses. Lead sulfate converts back into lead and lead dioxide, and the battery returns to full capacity. But the reversal is never 100% complete. Every single charge and discharge cycle leaves behind a thin residue of lead sulfate crystals that do not fully reconvert. They stay on the plates, they harden. They calcify, they grow. Over weeks and months and years, those hardened sulfate crystals accumulate on the active surface area of your battery plates like calcium deposits building up inside an old water pipe. Less exposed plate surface means less chemical reaction area. Less reaction area means less capacity. Less capacity means less cranking amps. Less cranking amps means your engine cranks slower and slower on cold mornings until one day you turn the key and hear nothing but a click. Your battery did not die because it wore out. It died because it was buried alive under its own chemical waste, and every battery manufacturer on Earth knows this. Engineering studies have consistently demonstrated that sulfation is the primary failure mechanism in 80% of all lead-acid battery failures. Not plate corrosion, not acid depletion, not separator breakdown, sulfation. And the industry's response to this known, documented reversible failure mode has been to design batteries with a predictable 3 to 5 year sulfation timeline, then sell you a replacement on the same cycle, year after year, decade after decade. They even had the audacity to market it as an upgrade. Maintenance-free sealed batteries were introduced and sold to consumers as a convenience feature. What they actually accomplished was removing your physical access to the battery cells, eliminating your ability to inspect the plates, check the electrolyte level, or treat the sulfation yourself. They did not solve the problem. They sealed it shut and put a warranty sticker over it. In 1935, a German electrochemist named Dr. Karl Reinhardt was working at the Kaiser Wilhelm Institute for Physical Chemistry in Berlin, studying the crystalline structure of lead sulfate deposits on battery plates under a military research contract. Reinhardt had observed that batteries operating in certain field conditions, specifically batteries whose electrolyte had been contaminated with trace mineral compounds from impure water used during emergency field refills, showed dramatically reduced sulfation rates compared to batteries maintained under laboratory clean conditions. He isolated the cause to a specific magnesium compound that was present in the mineral-contaminated water. When dissolved in sulfuric acid electrolyte at precise concentrations, this compound disrupted the ionic bonds holding hardened sulfate crystals to the lead plate surface. The crystals did not merely soften, they dissolved. They broke down into free sulfate ions and lead ions that re-entered the electrolyte solution, restoring the original reactive surface area of the plates, as if the sulfation had never occurred. He published his findings in 1937 in a German electrochemistry journal. The paper documented capacity recovery of 65 to 80% in cells that had been sulfated for over 18 months. Within 2 years, his research contracts had been acquired by a consortium of European battery manufacturers. His subsequent funding applications were systematically denied. His published work was never translated into English. His name disappeared from international citation indexes within a decade. The chemistry never changed. The access to it did. Let me show you the precise size of the machine that has been profiting from your battery's sulfation for the past 80 years. The US automotive battery replacement market generates approximately $14 billion per year in direct consumer spending. AutoZone alone reported $17.4 billion in total revenue in fiscal year 2023. Battery sales and installation are among their highest margin product categories. O'Reilly Auto Parts reported $15.8 billion. Advance Auto Parts reported $11.2 billion. Interstate Batteries, the largest replacement battery distributor in North America, moves over 18 million individual batteries per year through a distribution network that touches every parts counter, every Costco automotive section, and every independent repair shop in America. Combined, the battery replacement ecosystem, manufacturers, distributors, retailers, and installers, represents over $28 billion in annual revenue in the United States alone. Every single one of those dollars depends on a single assumption, that a sulfated battery is a dead battery. That assumption is worth $28 billion per year, and it is chemically false. Now run the numbers on what this formula does to that revenue model. Americans replace approximately 150 million car batteries every year at an average retail cost of $200 per battery. If even 60% of those batteries could be restored to functional capacity for under $1, the replacement market loses $18 billion annually. Not reduced, not redistributed, eliminated, because drivers would stop showing up at the parts counter every 3.5 years with a battery that could have been saved for less than the price of a postage stamp. $18 billion per year is not a variance that Interstate Batteries' board of directors reviews with mild concern. It is an existential threat to a publicly funded industry. Their response has been to fund research that classifies sulfation as irreversible plate degradation in every SAE and BCI technical standard, to lobby for sealed maintenance-free battery designs that physically prevent consumer access to the electrolyte, to train every parts counter employee in America to run a 15-second conductance test and print a receipt that says, "Replace the moment voltage drops below a threshold," that has nothing to do with whether the battery is actually recoverable, and to maintain vendor relationships with every major automotive media outlet that create financial incentives to never publish the word desulfation in a positive context. The average American household replaces a car battery every 3.5 years. Over 30 years of driving, that is 8 to 9 replacements per vehicle. At today's prices, that is $1,600 to $2,500 per vehicle in battery costs alone for a failure mode that costs $1 to reverse. 2-car household, double it. 3-car family, triple it. Every battery you have ever thrown away was a battery that could have been saved. Every $200 receipt from AutoZone was $199 that did not need to leave your wallet. But before I give you the formula, I need to tell you what else is waiting inside this vault. Emergency methods for restoring corroded electrical connections that mechanics charge $300 in diagnostic fees just to locate. Off-grid battery bank configurations developed by military engineers for field hospitals and forward operating bases. Designs that were removed from public training manuals within 5 years of publication. A technique for testing your alternator output with a $3 multimeter that tells you in 90 seconds flat whether your charging system is silently killing your batteries faster than it should. Complete technical guides, no filler, no upselling, just the knowledge that industries generating trillions in annual revenue have spent decades and billions of dollars keeping out of your hands. But stay right here. Because the chemistry behind this battery tablet is about to make every dead battery you have ever hauled to the recycling bin feel like cash you threw in the garbage. Here is exactly what happens at the molecular level when this compound enters your battery's electrolyte. The active mechanism is electrochemical desulfation through controlled ionic dissolution. When the compound dissolves in the sulfuric acid electrolyte, it increases the solution's ionic conductivity and introduces competing ions that directly attack the crystal lattice structure of hardened lead sulfate deposits on the battery plates. Lead sulfate normally forms stable orthorhombic crystals that resist reconversion during standard charging. The molecular bonds holding those crystals to the plate surface are stronger than the electrical energy your alternator or charger can deliver at normal charging voltages. That is why charging alone cannot reverse hard sulfation. That is why pulse desulfation chargers produce marginal results. You are trying to break a molecular bond with electricity, and the bond is stronger than the current. This compound works differently. It introduces magnesium ions into the electrolyte that compete with lead ions at the crystal surface. The magnesium ions weaken the lattice bonds holding the sulfate crystal together, reducing the energy threshold required for the crystal to dissolve back into the electrolyte as free sulfate and lead ions. Once those ions are free, a standard charger provides more than enough energy to drive them back into the normal charge-discharge reaction. The plates are exposed again. Active surface area returns. Capacity returns. Cranking amps return. This is not theoretical chemistry. A study published in the Journal of Power Sources confirmed that electrolyte additive treatment of sulfated lead-acid cells restored up to 70% of lost plate surface area in cells that had been sulfated for over 18 months, producing a measurable increase in capacity across all tested cell configurations. Research published in the Journal of the Electrochemical Society documented that ionic additive treatment reduced sulfate crystal adhesion to lead plate surfaces by 44% under standard ambient temperature conditions. The mechanism has been studied and documented in peer-reviewed engineering literature for over 60 years. The science was never in doubt. The access was. Now let me explain why the products that currently exist on the market do not do what this tablet does, even though some of them use the same active ingredient. Pulse desulfation chargers like CTEC and NOCO attack sulfation with electrical energy. They send high-frequency voltage spikes through the plates, trying to physically fracture the sulfate crystals. It is brute force. It works partially on soft sulfation, crystals that are less than 6 months old and have not fully hardened. On hard sulfation, crystals that have been calcifying for 2 or 3 years, it barely registers. Chemical desulfation works at the molecular level. It does not crack the crystal. It dissolves it from the inside out. It reaches sulfation that electrical pulses cannot physically penetrate. It is the difference between hitting a kidney stone with a hammer and dissolving it with medication. One is violent and partially effective. The other is precise and complete. Battery additives do exist on the commercial market. Battery Minder sells a treatment. Battery Equalizer sells a treatment. Volt Restore sells a treatment. They cost $15 to $30 per bottle. And their primary active ingredient is the exact same compound you're about to buy at any grocery store for 67 cents per pound. You are not paying for chemistry. You are paying for a label and a plastic bottle. I need to be completely honest with you about what this formula can and cannot do before you use it. This treatment produces its strongest results in standard flooded lead-acid batteries, the most common battery type in vehicles manufactured before 2020, the kind with removable cell caps or pry-off cap strips that give you direct access to the electrolyte inside each cell. These represent over 70% of batteries currently on the road. On these batteries, capacity recovery of 70 to 85% is consistently achievable with 1 to 2 treatment cycles. AGM batteries, absorbent glass mat batteries, which are increasingly common in newer vehicles and start-stop systems, show more modest results because you cannot easily access the electrolyte without modification. Treatment requires drilling small access holes in the cell covers, injecting the solution with a syringe, and resealing with silicone plugs. It works, but results are more modest. Expect 40 to 50% capacity recovery rather than 70 to 85. This treatment will not work on batteries with a physically shorted cell, an internal structural failure you can identify by a single cell reading dramatically lower voltage than the other 5. It will not work on batteries with swollen or bulging cases, which indicates thermal damage to the internal plate structure. And it will not meaningfully restore batteries that have been sitting completely discharged for more than 24 months, because prolonged deep discharge causes irreversible plate damage that no chemical treatment can reverse. One important safety note: you are working near sulfuric acid. Wear safety glasses, wear nitrile gloves, work outdoors or in a well-ventilated garage. If electrolyte contacts your skin, flush immediately with clean water for 15 minutes. Do not lean directly over the battery during or after treatment. Hydrogen gas vents from cells during charging, and hydrogen is flammable. Basic safety around battery acid is non-negotiable. If your battery has a cracked case or a confirmed shorted cell, no additive on Earth will save it. Replace it. But if it is sulfated, and statistically 80% of dead batteries are, this formula costs you $1.48 before you spend $200 on a replacement you may never have needed. Here is exactly what you need. Total cost, under $1 per treatment. Under $4 for a full year of preventive maintenance on every battery you own. Epsom salt, standard magnesium sulfate. Available in the health and beauty aisle of any Walmart, CVS, Walgreens, or Dollar Tree for $1 to $3 per bag, enough for 15 to 20 battery treatments. Must be pure magnesium sulfate. Check the label. Epsom salt sold for baths with added lavender, eucalyptus, or any fragrance will not work and will contaminate your electrolyte. The bag must say 100% magnesium sulfate or USP grade, nothing else. Distilled water, standard distilled water from any grocery store or pharmacy, under $1 per gallon. Do not use tap water, do not use filtered water, do not use spring water. Mineral content in non-distilled water introduces impurities that accelerate plate corrosion and create new problems worse than the one you are solving. Distilled water only. This is non-negotiable. A plastic mixing container, any disposable cup, a plastic spoon or stirring stick. No metal. A turkey baster or large plastic syringe for delivery into the cells. Total equipment cost under $3. You probably already have everything in your kitchen. Step 1. Prepare the solution. Dissolve 1 tablespoon, approximately 15 grams, of Epsom salt into 1 cup, 8 ounces, 240 milliliters of warm distilled water. Stir until completely dissolved. The solution should be perfectly clear with no visible crystals remaining at the bottom. Warm water dissolves the magnesium sulfate faster. Do not use boiling water. It will evaporate before you can work with it. This volume treats one standard 12-volt automotive battery with 6 cells. Step 2. Access the cells. Open your hood and locate the battery. If your battery has removable cell caps, twist or pry them off. You will see 6 individual cell openings. If your battery has a flat-sealed strip across the top, this strip can usually be pried off carefully with a flathead screwdriver, revealing the cell openings underneath. This works on the majority of so-called maintenance-free batteries despite the labeling. Maintenance-free means they do not want you maintaining it. It does not mean you cannot. Step 3. Check the electrolyte level. Look into each cell. The electrolyte should cover the top of the plates by approximately ½ inch. If any cell is low, top it off with plain distilled water before adding the treatment solution. Never add the Epsom salt solution to a cell with exposed plates. Step 4. Add the solution. Using a turkey baster or plastic syringe, draw the Epsom salt solution and distribute it evenly across all 6 cells. Each cell receives approximately 1/6 of the total solution volume, about 40 milliliters per cell. Do not overfill. The electrolyte level should not rise above the cell's fill line, usually a molded indicator visible just inside the cell opening. Replace the cell caps when finished. Step 5. Charge the battery. Connect a standard battery charger, any charger, 2 amp to 10 amp, and charge the battery on a slow or trickle setting for 24 to 48 hours. The slow charge is critical. It provides the sustained low current energy that gives the magnesium sulfate time to interact with the sulfate crystals and dissolve them progressively. Fast charging bypasses this reaction window entirely. If you own a smart charger with a reconditioning mode, use it. But any basic charger works. The compound does the chemistry. The charger just provides the energy to drive the reaction. Step 6. First cycle evaluation. After 48 hours of charging, disconnect the charger. Let the battery rest undisturbed for 2 hours. Test the resting voltage with a basic multimeter, available at Harbor Freight or Amazon for under $5. A fully healthy 12-volt battery at rest reads 12.6 volts or higher. A sulfated battery typically reads 11.8 to 12.2 volts. After one treatment cycle, most batteries recover to 12.4 to 12.6 volts and produce noticeably stronger cranking performance. Most drivers see 50 to 60% capacity recovery on the first treatment. For severely sulfated batteries, those with 2 or more years of accumulated degradation, repeat the treatment one additional time after driving the vehicle normally for 1 week. The second cycle typically brings total recovery to 70 to 85%. The improvement is cumulative because each treatment dissolves an additional layer of sulfate crystal that the previous treatment exposed. Think of it like descaling a coffee maker. The first cycle breaks through the worst of the buildup. The second cycle clears what the first one uncovered. After 2 treatments, most batteries will test at a level that a parts counter conductance tester grades as good, the exact same battery that the same machine graded as replaced 2 weeks earlier. For preventive maintenance, treat your battery once every 6 months, spring and fall, before the temperature extremes that accelerate sulfation. Annual cost of preventive treatment is under $2 per vehicle. Compare that to the $200 replacement you are currently scheduled to buy every 3.5 years. A $200 battery every 3.5 years is $57 per year per vehicle for a part that fails from a condition you can reverse for $1. Over 10 years of ownership, preventive treatment eliminates 2 to 3 battery replacements entirely. That is $400 to $600 saved per vehicle. 2-car household, $800 to $1,200. And that is a conservative estimate because it assumes you were buying the cheapest battery on the shelf. If you drive a vehicle that requires an AGM battery, your replacement cost is $250 to $350 each. The savings multiply accordingly. Now scale that across the 280 million registered vehicles in the United States. 150 million replacement batteries per year, multiplied by $200 average cost, multiplied by 60% that are recoverable from sulfation. That is $18 billion per year moving from American wallets to parts counters, battery manufacturers, and recycling processors. For a failure mode that a tablespoon of a compound costing 67 cents per pound completely reverses. Now you understand why you have never heard of this. Your grandfather replaced batteries in cars that came from the factory with cell caps you could open with your bare thumb. He could look inside, see the plates, check the acid level, and maintain the battery himself with nothing more than a flashlight and a jug of distilled water. Then the industry introduced sealed, maintenance-free designs. They were marketed as a convenience. No more checking, no more topping off, no more getting your hands dirty. What they actually accomplished was removing your access to the only component inside the battery that you could service yourself. They replaced user-serviceable cell caps with tamper-resistant covers. They trained every parts counter employee in America to run a 15-second electronic test and hand you a printout that said "replace" before you could even ask whether the battery was fixable. They did not make batteries better. They made batteries harder to fix and easier to sell. The chemistry has not changed since 1859. Lead plates, sulfuric acid, sulfation. The only thing that changed was your ability to do something about it. Dr. Karl Reinhardt published the solution nearly 90 years ago in a journal that was never translated, in a language that the American automotive industry had no interest in making accessible at a time when the replacement battery market was just beginning to realize how much money could be made from a failure mode that the customer could not see and did not understand. A tablespoon of Epsom salt, a cup of distilled water, a $30 charger you already own. That is everything standing between you and a battery that lasts 3 times longer than the industry designed it to. Subscribe and share this with one person you know who jumped their car this winter and got told at the parts counter that their battery was dead. Every share is $200 that stays in a real person's checking account instead of flowing to a parts counter that graded a recoverable battery as trash. Every like tells the algorithm that a $1 tablespoon of Epsom salt from the Dollar Tree matters more than a $280 receipt from a company that reported $17 billion in revenue last year and still charges you a $15 installation fee to bolt in the replacement. The next vault opens soon, and what is inside it will make everything you heard today feel like the first page of a very long manual they never wanted you to read.